Hello everyone, welcome to Stats class with Mr. Vrandrick. We're in Room 101 with my second period. This class is brought to you by Marbles. Marbles, the game that's so old, if you've played it, you're old. All right, so in this problem, what I like to do when I organize the information that's given, to the side, and you also have a blank slide as well if you want to use the blank slide, but I like to put the information that's given in terms of my probabilities. So the first one they give me is the probability that the car is US made. So what's the likelihood that the car is US made? 40%. I'm going to write 0.4.
You lost the screen.
What about the probability, well played, Suzette, of it being made in Japan?
0.3.
0.3. What about Germany?
0.1.
Very good. And other countries?
0.2.
Very good. Now, as a check, do we feel good about those probabilities?
Yes, because they add up to 1.
Very good. They add up to 1, so I feel good about that. This is talking about cars in our area, so let's just say the greater Houston area. How many cars do you think the city of Houston has?
5 million.
5 million?
5 million.
5 million? More than that? 10 million? 50 million? I'm not sure about 50 million. 20 million? Let's go with 5 million. Sound good? Doesn't matter. That's all those numbers are a lot. Okay, so 5 million cars. So the idea is, if I go out to find a random car, and I pick up that car, underneath it'll say made in whatever the country is. In our example, China would be in other countries, because that's not one of the other ones there. Okay? All right, that's what it says on my son's Hot Wheels cars, but not on those out there. But that's all right. So, what's the likelihood that a car is not U.S. made? So I'm going to write U.S., but then I'm going to write a little tiny letter C. For what? For complement. Very good. So I'm going to do 1 minus U.S. made, which is 0.4. So what is the likelihood that I walk out into the street, find a random car, I pick it up, look at it, and it says made in, not US, 0.6. I know, thank you. See me on the next Avengers movie. You made it! And you got out of it, look at that. Oh, you didn't, okay, sorry. It's who you know. It's all about who you know. All right. Oh, you're just going to trade food for PHs? I like it. All right. What's the likelihood that a car I look at is made in Japan or Germany? So I said or, so we're taking addition. Okay, so I'm going to write down P, probability of Japan or Germany. Now, I heard people have already answered this, which you're probably correct, but I'd like to stop and pause and make sure it's okay to add them. What do I have to think about to make sure it's okay to add these two probabilities? I need to see if they're disjoint. So when I pick up a car and look at where it's made, how do I know if they're disjoint?
It's not made in 2 places.
Because it can't be made in 2 different countries. Exactly. All right, if I look at the car and it says made in Japan, then I know it could not have been made in Germany. Okay? So they're disjoint. So it's okay to add them. So we have 0.3 plus 0.1, which is 0.4. Yes, George.
Is it similar to like the iPhones, how like they're engineered in California but made in China? Is that like?
Well, I think that's more of the manufacturing of like the hardware as opposed to the software, right?
Yeah.
So I think that's a little different. And again, I'm simplifying cars, right? Ultimately, all pieces of cars are made in many countries. So I'm taking a complex world issue and simplifying it for the idea of probabilities. So I'm sorry. Now, I want to say something about these first two so far. Have you seen me write a percentage? No. Okay? But if you wanted to, like for this one, the probability that a car is made in Japan or Germany is 40%. If you were to say it or to write it out, that's when you would use the percentage. All right? But in terms of work with decimals. Everybody good on that difference? So on the quiz tomorrow, you do not need to write it out or say it to me. You can just leave it as a decimal. Good question. I am checking for notation. That's what all this is here. The notation, and then yes, your work. The C stands for complement. Complement. Let's try the next one. The next one makes it a little more challenging because now we're talking about two cars. So I pick up a car, made in Japan. Put that one to the side. Pick up another car. Oh, also made in Japan. Put that one to the side. What's the likelihood that I get two Japanese cars in a row? I'm not sure that was funny. Yes, I know I'm not actually picking up the cars. You mean this car?
Yes.
What should I do? Japanese car and Japanese car. That's multiply. So I'm going to write down P, so probability of Japanese car and Japanese car. Now we're going to multiply 0.3 times 0.3, but let's pause for a second. Using this rule of multiplication means we assume what about looking at a car, finding out where it's made, putting it to the side, and looking at another car. We're assuming what about those two events? That they're independent. So now here's the thing. You ready for this? Imagine millions of cars out there. I mean, I'm looking at like 14. It's amazing right now. Millions of cars out there in Houston. If I pick one up and look at it, oh, made in Japan, and put it to the side, take it out of all of those millions of cars, what happens to the probability of getting a Japanese car on the next one? Very good. It goes down. What happens to the probability of getting any of the other ones? It goes up. But it's millions of cars. So when it goes down and the other one goes up, it's so small, it doesn't matter. So we're going to break the rule. Even though we're breaking the rule, and we just said we are breaking it. That is, they are not independent. Because the change is so minuscule, we can keep going. Okay? Now, your brain might be thinking, how do you know when the change is small enough that it's okay? And when do I know when it might not be okay? That's a great question. Second semester. Excellent. Tune in next time. So we have 0.3 times 0.3, which is every time 0.09. Every time I do that, everyone says 0.9. Remember, think about it. If you're taking a number and multiplying it by a number that's less than 1, it's going to decrease your number. Don't need to apologize. So what's the likelihood that I see a Japanese car and then I see another Japanese car right after it? 9%, or 0.09. All right, so just under 10% chance of that happening. Let's keep going. All right. We're going to get more challenging here. All right. The next problem says none of the three cars that you look at are from Germany. So I pick one up.
Not Germany.
Great, Japan, not Germany. Put it to the side. Pick another one up.
Not Germany.
Not Germany. Pick another one up. not Germany. So what's the likelihood I have not Germany, and not Germany, and not Germany? So I'm going to write down probability of G with a little c, and G with a little c, and G with a little c. So if the probability of getting a German car is 10%, what's the probability of getting not German? 90%, so 0.9. Now you could write 0.9 times 0.9 times 0.9, but I'm going to write 0.9 cubed. So you could, if you want to show me, like if you were really thorough, yeah, you would have like 1 minus 0.1 times 1 minus 0.1, but that, I think you can do that mentally. That sound good? Yeah. Yes, cube it. So 0.9 times 0.9 times 0.9. What is that? No, 9 times 3 is 27. 9 times 9 times 9 is not 27.
81. 81 times 9. It's a big
It's a big number. It's actually a smaller number. Okay, excellent. Very good. Well done. 0.729. Yeah, those are different. 0.729. So, what's the likelihood that the 3 cars we look at in a row are not German? Almost 73%. That's pretty likely. Which makes sense, because German cars make up what percentage of all the cars? 10%, which is not high. How are we feeling so far?
Good.
Got 2 more, and this next one is the hardest one. I'm going to put an asterisk next to it, because in doing this for almost a decade, so many students mess this up. Anytime I read at least, I think, oh man, this one's the doozy. All right, this one's challenging. So when I see at least, I'm like, okay, Mr. Vandrick said, I really got to think. Are you ready?
Yeah.
Okay. At least one of the 3 cars I look at is from the US. Let's think about that. So are you thinking about 3 cars? Okay. 3 cars. Okay. Oh man, they're nice cars. They're all orange, my favorite color. Okay. So if I think at least 1 out of 3, it could be the first one. Just the first one, right? That's 1 out of 3 at least. It could be just the second one. It could be just the third one. It could be the first 2. It could be the second 2. It could be all 3 of them. All right? So 1 out of 3, 2 out of 3, or 3 out of 3 would satisfy that. What would not satisfy that?
0.
0 out of 3. None out of 3. We're not looking at 4. None out of 3. So I want to focus on that. What's the probability that none of the first 3 are US made? So I'm going to write US with a C, and US with a C, and US with a C. Now again, is the problem asking me to find that? No. But I want to find what's the probability that all 3 are not US made. Well, what's the likelihood that the first one is not US made? 60%. All right? What's the probability that the second one is? 60%. The third one. So I'm going to do 0.6 times 0.6 times 0.6, or 0.6 cubed. Okay? Now, am I done? No, because that's the likelihood that none of them are. But I want at least 1 out of 3. That's the complement of this. So I'm going to find the probability of at least 1 is US is equal to 1 minus 0.6 cubed. Let's try that again. Okay? What's 0.6 cubed? 0.216. What's 1 minus that? Very good, Aaliyah. So what is the likelihood that at least one of the three cars that we look at is from the US? 78.4%. That's fairly high, which makes sense because what's the largest percentage of manufactured cars in this whole group of cars? The US is 40. That's the highest. So this is 0.216. And then 1 minus 0.216 is 0.784. Now, I'm going to have you pause your brain on that question. After I finish the recording, I want to do it like an extension of why I do it that way. Because there's another way to do it, but it's much longer. But I want to show you the long way, so you can be like, yeah, Mr. Brandrick, we should do it that way. Okay? Everybody good? So we'll come back to this. All right? And there'll be some colors. I know. Exciting. The last question. The first Japanese car that you see, oh, not Japanese. Oh, not Japanese. Oh, not Japanese. Oh, Japanese! Is the fourth one. So I did not Japanese, and not Japanese, and not Japanese, and then it was finally a Japanese car. So this one's going to be a J with a little C. Your initials, George? Mm-hmm. A J with a little C. And someone else, right? Jacob? Jacob. Is there a third one in here, or do you guys have this, just two of you? Or something just... There can only be two of them. There can only be two? Yeah. Okay. So I'm going to write down what's not Japanese made if 30% of the cars come from Japan. 0.7. So 0.7 cubed, right? There's three of them that are not Japanese made. And then finally, it is from Japan. 0.3.
Why didn't you do the first one 4 times, not 3?
Ooh, good question. So the first one that's Japanese is the fourth one. So it was not Japanese, not Japanese, not Japanese, then Japanese. So that's why I only did 3 not, and then 1 that is, because the last of the fourth one is.
No, I'm saying.
Oh, sorry.
Beginning.
The beginning.
Like you did J, C 4 times. G.
Did I do it 4 times? I'm doing it 3 times. 1, 2, 3, and then it's Japanese. So this is not Japanese, not Japanese, not Japanese, Japanese. Is that, yeah? Okay. So what's that? What's 0.7 cubed times 0.3? Thank you, Aaliyah, for doing it. So 0.103. 0.103. So we have basically a 10% chance of that happening. Okay? Oh no, did I just delete it? Oh, no. All right, thanks for watching this video. I hope you enjoyed it. Make sure to like and subscribe. And don't forget, next time you're at Target, try to find those marbles. If you can, good luck. I don't know if they're there.